Everybody. So in this video, we're going to talk about how negative feedback loops help to monitor and ensure that our hormones are regulated and maintain balance. So specifically, we're going to be focusing on negative feedback loops. Real quick overview of negative feedback loops. Again, I do suggest that you guys take a look at that on your own. But again, just as a reminder, let's talk a little bit about, let's say, body temperature. So let's say this line here in purple is your normal body temperature. Sometimes your body temperature will increase. So your body will do something. You like how vague I am? Your body will do something to bring it back down. In our case, with body temperature, you're going to sweat. You sweat, you cool down. Or your body temperature goes down. When it goes down, your body will do something. Again, in this case, shiver and bring your body temperature back up. So again, negative feedback loop is not bad. Negative is not bad. It just means we're going to do the negative. We're going to do the opposite. So if you go up, we're going to bring it down. So if your body goes up, we're going to bring it back down. If your body goes down, we're going to bring it back up. So that's just a general example of a negative feedback loop. So now let's go and take a look at some examples. So if we're looking at hormones in the body, one great example could be right here. Your hypothalamus can tell your anterior pituitary to release hormones. In turn, just like we talked about in the previous videos, this is kind of like a domino effect in this case. It's going to tell another part of your body to release additional hormones. From there, this hormone, or the hormones from this gland, can then go to their target cells and complete an action, right? We achieved our goal, we're happy. So one more time, I'll do it in blue this time. Hypothalamus tells the anterior pituitary, or another gland, to tell, by releasing a hormone, to release another hormone, which then goes to a cell and binds to it, whether it's non-steroidal or steroidal hormones, bind to them, and then you get your desired function. Hooray. That's what we got, smiley face. Now, with that said, if you have too much of this in your system, your body's going to recognize this and send feedback, such as this hormone here. You're going to notice this in your blood. Your brain's going to notice this. And from there, your body's going to stop those signals, right? So in this case, you're going to see once these hormones are released, you're also going to, it's going to be in your blood. Once it's in your blood's going to send a signal to your brain and say, hey, maybe we shouldn't have so much of this in here, and then tell them to stop sending those hormones, right? So that's going to be the important thing here. You're going to release hormones, they're going to get into the bloodstream to do a job, but because they're in your bloodstream doing a job, your body's going to recognize them and then tell your body, you know what, we don't need this much, and then slow it down. This is going to give you that desired effect of increase, and then your body's going to recognize it, lower it. Increase, lower it. And we're going to maintain balance. And then here are a couple other examples of a very similar thing. Right, so in this case, I'll do the second one as well. Your nervous system is going to send a signal to some gland in the body, which then is going to release a hormone, which hits a target cell, which gives you a desired action, and you did what you wanted to. But because that happened, your brain recognizes that you did that desired action and then tells your body to stop releasing that hormone. So therefore, this gland stops sending the signals or stops releasing the hormone. So therefore, the cells stop getting any hormones. And so therefore, the action will stop, and then you balance back out. Again, you add some, you take some away. Just like I talked about, your hormones are always in constant fluctuation. So on average, that's this line in the middle. This is your average line. So on average, you have a certain amount of hormone. So if you ever get blood work done, you'll see, oh, this is This is how much of a hormone I have in my body. However, what you're not seeing, or maybe what you are seeing sometimes, is the fluctuation, right? So when a doctor compares your blood to the average, you may be where this blue dot is. Today you may have low hormones. Tomorrow they might be a little bit higher, right? But you're trying to see if you're within this range. The problem is when you notice that your hormone is somewhere else. And that's where we can recognize that's not a good thing. But anyways, besides the point, my point I'm trying to make here is just that they're constantly fluctuating. Your hormones are always going up and down because of that negative feedback loop. You're always adding and removing hormone from the system. And here's another example here, hormones targeting their organs, and here are more specifics to what I was just doing before. And this is one of the challenges of going through this unit because there are different hormones and the way they work are slightly different. So let's just take a look here. We have TRH. So TRH is going to then bind to create or to release TSH or thyroid stimulating hormone. So in other words, it is going to release more of this thyroid hormone. Another example is prolactin releasing hormone or prolactin inhibiting hormone. So in other words, a different in your hypothalamus, your brain, it's going to tell you to release prolactin, or it's going to tell you to not release prolactin. That's the inhibiting hormone, right? So again, that'll affect your anterior pituitary and tell it to create or not create prolactin. Let's do another one. I'll do it in this. I'll do purple, right? CRH, corticotropin releasing hormone. If it's released from your hypothalamus, it's going to go to your anterior pituitary, and then your anterior pituitary is going to release ACTH, adrenocorticotropic hormone, and then that's going to go to your adrenal gland to release adrenaline. Another example is GnRH, gonadotropin releasing hormone. This gets released from your hypothalamus, goes to your pituitary, and will release one of these two hormones, depending on if you're a male or female, and depending on what scenario you're in. We're going to learn about this a little bit more with reproduction in future lessons. But we have luteinizing hormone and we have follicle stimulating hormone, which are going to have different effects on your ovaries and testes depending on whether in females if you're pregnant or not, if you're going through menstruation, if you are a male. There's different combinations, different things that these hormones will do. And then lastly, over here, we could talk about growth hormone releasing hormone, which is exactly that. It is going to release growth hormone. So your hypothalamus is going to tell the anterior pituitary to release growth hormone, which will then go to your body and help your body to maintain homeostasis by telling your bones, your muscles, fat, a whole bunch of different parts of your body to grow. So again, if there's any questions you guys have with any of this, please let me know.